Hi, we are going to talk about variations of conditional statements. So if we consider a statement, if today is Friday, then lizards sleep. In this format, we consider today's Friday to be the hypothesis, and a lizard sleep is called the conclusion. And this one's going to have three different variations. So it's going to have the converse, which is when you switch the hypothesis and conclusion, and you can see that. The inverse, when you negate both hypothesis and conclusion. And finally, contrapositive, which is when you switch and negate both hypothesis and conclusion. You can see what these statements are going to look like. They are written there. Okay, let's practice this. What does it look like symbolically? Conditional will be P implies Q. Converse, since you switch hypothesis and conclusion, will be Q implies P. Inverse will be when you negate both hypothesis and conclusion will be not P implies not Q, and the contrapositive will be not P implies not Q implies not P. Let's take a look at example 1 and try to write this. If Mondays are sad, then birds don't sing. So to write the converse, you write if birds don't sing, then Mondays are sad, right? And Mondays are sad. Inverse will be obtained by negating both. So if Mondays are not sad, then birds sing. And the contrapositive is the one where you both negate and switch. So if birds sing, then Mondays are not sad. Okay. Example 2, if you don't eat breakfast, then birds sing. So if you don't eat breakfast, then birds sing is our conditional. The converse will be when you switch them, if birds sing, then you don't eat breakfast. Inverse will be if, so this is when you negate, if you eat breakfast, then birds don't sing. And finally, the contrapositive will be when you negate and switch, if birds don't sing, then you eat breakfast. We're going to take a look at this example. What is that going to look like if the conditional is given as in this form? It's a little bit of critical thinking. So remember, what do you do for converse? You switch. That would be P implies not Q. Inverse is when you negate. That would be Q implies not P. And contrapositive will be switching and negating. It will be not P implies Q. Let's complete the truth table for P implies Q, and then not Q implies not P. So P implies Q, we should be familiar with this by now. That's going to be true, false, true, true. Let's take a look at this one. So not Q will be false, true, false, true. Not P will be false, false, true, true. And not Q implies not P will give us true, false, true, true. So, because they have the same exact condition, the truth tables are identical, then the conditional, and this happens to be the contrapositive of the original statement, and it's contrapositive turn out to be equivalent. Same goes also for converse and inverse. What that means is, it means that if the conditional statement is true, its contrapositive is also true, and vice versa. And please be careful of making assumptions about the true statement, you know, whether it's true or not. Like if you live in Russia, then you live in Moscow. The converse of that will be, if you live in Moscow, then you live in Russia. The inverse will be, if you don't live in Russia, then you don't live in Moscow. And the contrapositive will be, if you don't live in Moscow, then you don't live in Russia. What I want to point out here is the conditional statement is actually a false statement, because you don't have to live in only in Moscow to live in Russia. You can live in St. Petersburg or a bunch of other places. But the converse is actually true. If you live in Moscow, then you live in Russia, provided of course Moscow, Russia. And the inverse is also going to be true. If you don't live in Russia, then you don't live in Moscow. So these two statements, converse and the converse and the inverse, are true, and both conditional and contrapositive are going to be false. Okay, so the last thing we want to take a look at, this. These are already written. If an angle is right and it measures 90 degrees is our conditional. The converse will be, if the measure of an angle is 90 degrees, then the angle is right. That is also true. If an angle is not right, then its measure is not 90 degrees. That is also true. And if the measure of an angle is not 90 degrees, then the angle is not right. All four statements here are true. Well, the conditional and the contrapositive will always be both true or false, so are converse and inverse. But if all four of them are true, then what you are going to have here, this is what we call a definition. Definitions are the ones that are going to be true all the way around. We basically define right angles as angles that are going to be 90 degrees. Okay, so that's all about that.